All right. Hello, everyone. I'm Professor Caudill. I really should start writing my L's kind of like this. Um, I think it would make my handwriting a little bit more legible. I've seen like other lecturers do the curved L's. Um, I guess it reduces ambiguity, which is always good. Um, so yeah, let me get a timer started. So shooting for an hour today, as usual. Um, so let me find where we were last time. I think we were at somewhere around here. Fireworks, I remember that. Okay, I think we're somewhere around here. Nope, we definitely did this one. All right, so as mentioned earlier, time for projectile motion. So let's just start here. Time of flight, trajectory, and range of interest. So time of flight, so that's how long it's in the air. Position and displacement in y must be 0. Okay, so set these equal to 0. And they said, so v naught y is v naught sine theta 0. So that's just simple trig. V naught x would be v naught times cosine theta. So I have no idea how they solve this. For t, how they solve this for t. Instinctively, I'm thinking, okay, take t times both sides. So v naught sine theta gt over 2 equals 0. So negative v naught so so you're dividing by 2, so 2 is that what they get? They get over g. Okay, so yeah. So I mean, I guess I lied. I can do it. Just I was kind of suspect. I was kind of fishy. Just getting rid of the T like that so easily. So time of flight is this time. Okay, so we should probably add that. Well, we don't really need to add this because what equation is this? 1/2 GT. Okay, so they're using equation 4 where x and x naught are 0. Only thing is they're changing v naught to v naught sine. Okay. So I wonder, for example, 0, let's say it's accelerating 10 meters per second, or we want to solve for time of flight. Initial velocity, let's say it's going, the initial velocity is 30 meters per second. So that's an arrow. But we want to break that arrow down into component forms, and we want to solve just for the y. So that would be 30 sine, 30 times sine, 30 degrees, but times pi over 180. 0. So we get something like that. So basically we have to be careful when we add these. So if it's 30 at 45 degrees, it's 21. So it would just be t times that. It's like I can combine these two blocks of code into one, but I don't want to get lost in the equations, because that's really the hardest part of using a calculator, is just matching the right equations to the problem. And I don't want to add unnecessary complexity to this. Trajectory. X is v naught times t. Replacing this with that, so t is x over v naught cosine theta. Okay, I mean, okay, so they're taking v I'm wondering why there's an x here. Is x the displacement? So you might be wondering where this tangent comes from. Tangent is sine over cosine. they're plugging this. Where did this come from? Factoring out the X here. Okay, so they're factoring out the X. And then, okay. Positive Y is 0. This, okay. I wish I was better at trigonomic identities. I didn't take trig in high school. So I know they're important to know. Um, so yeah, recognizing that is important. Sine 2's theta, saying XR. Okay, I'm getting lost. Getting lost over here. Radius R, is this radius or what? Where did this come from? So they're probably converting. The position is 0. Okay, so this is 0. Dividing both sides by x is still 0. Okay. So this would be negative cosine over sine. I'm trying to see the math in my head of how they're getting from here to here. Probably doesn't matter. I mean, our calculator should do it. We should know what functions. Like, I can't really see what calculator equation we have so far that would use that. So we're getting kind of information dumped right now. Trying to stay with it. Okay, so we have a visual here. 30, 40 meters, 50 meters. So I think this is the initial velocity. Greater initial speed, greater the range. (15 degrees) and 75 degrees. So it could be the same. Okay. So let's do our first example. We should probably spend some time on this one. Situation holes. Second hole. Is there a picture? No picture. 120 meters from green. Okay, so He wants to hit it 90. So he wants the ball to go like this. Okay, so theta's 30 degrees. Okay. Then when he is 90 meters away, okay. It's 120. So now he's 190. Now he's 90 meters. He wants to hit the ball 90 meters. Okay. Fourth hole, he's 90 meters from green. First he was 120, now he's 90. Wants to let the ball drop with a minimum amount of rolling. Okay, so he wants a higher apex. So he's going to do theta. Let's do 1, 2, 70 degrees. Okay. So we want to find V naught. Or absolute value of V naught. Okay, so we know initial is 0, final is 90, A is negative 9.8. Okay, we know V naught. I'm thinking we would use V naught times cosine. Okay. Maybe I should use Y. Let's use Y because okay. Yes, before we move into the strategy, let's see if we can figure it out ourselves. I'm trying to find V naught. Okay, here they're given, you're just given the vector. We're not given it. Okay, so is there any other way we could find velocity? Velocity is distance times time. We don't know time though. So I'm gonna give up, see what they do. Range, an equation, initial speed. They're using R. It's V naught. Okay. R is V naught. It's like, where did that come from? So the range is this. Okay, so they're solving for, okay. I get what they're doing. Kind of. Like I know they're doing I know how they're doing the algebra. I want to say I know how this becomes velocity. All right, so they're taking this, solving for, that's a G R V naught squared. Square root of GR over sine 2 theta. Okay. Let's go ahead and add this to our equations. So define R. R is 90. Okay. Let's see what they're saying. So V naught is square root of A times X, A times X minus X naught. Okay. Sine 2 times theta. So we need theta. Um, Yep. Oh, so many parentheses. Theta is not defined. Okay. Okay. We're gonna do equation 6. We still have to add it. So 6 is F6. V naught. Okay, so V naught A X V naught A X X naught theta 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 theta. Okay, we want to solve V naught V naught V naught theta for theta theta. Okay. Here's the hard part. If we select 6, V naught, A is that, okay. X and distance, yeah, the initial, okay, and theta theta, turn A, and theta theta. Okay. Kind of a lot. Kind of a lot, not gonna lie. See if this works. Okay, we missed displaying it. We want to display it. Okay. F6. What is this? What is this called? Range. Oh. Disregard. Right here. F5. F5, I forgot a comma. Okay, I think it's working. Alright. F6. Initial velocity. That's what we're solving for. Negative 9.8. End distance 90, 0, and 30 degrees. Okay, VV is not defined. VV, we want V naught, V naught. Okay. 6, initial velocity is V naught. Negative 9.8, 90, 0, 30. Okay, getting a complex, not a complex number. Just have to make sure everything's in the right order. Okay. Do I add something here? V. Why is it giving me V? I don't want V. I want V naught. F6, V naught. V times V naught. Okay, so where are we getting the V from? Function 6. We accept V. Okay, function 6, V naught. Equation 6. Equation 6. Okay, there we go. All right, 6 V naught, negative 9.8, 90, 0, 30. We're getting something ugly. 31. Okay. So we're getting the right answer. Maybe it has to be absolute value. Velocity has to be absolute value. Should it be absolute value? Okay. This is tough. Let's say V absolute value of this. Will that change it? Shouldn't. It did. Okay. Okay, this is tricky. Okay, I know, because we didn't, 6. B naught, that's what we should have done. Negative 9.8, 90, 0, 30. So how do we get rid of the I? I think it has to be, because we're taking a square root of a negative number. So maybe it's gravity. Let's try positive. So B naught, 9.8, 90, 0, 30. Okay, so they're using positive gravity. Okay. So yeah, they are using positive gravity. C, part C, they're doing the direct trajectory. Okay, so now we need to add trajectory. Okay. Oh man. I really hope this pays off. All right, so trajectory. We're gonna write. Going to write y. It's kind of insane how much I have to add just to do this. No problem. So x times tangent theta, tangent rad. Oh man, tangent rad theta. Okay. Minus a divided by 2 times v naught cosine theta squared. Cosine rad theta squared. 2 times that. 2 times parentheses okay, what is this? This is trajectory calculates. Okay. So what are our variables here? We have y. I call this yy. Okay, I guess we're calling this yy. Let me see if it displays right. Yeah, I need a this. Okay, so that is our equation, I think. Let me make sure. So x times tangent theta minus gravity over. Okay, so we're messing up the parentheses. 2 times this. Okay. So I think that's fine. You can distribute v naught is 4 times 3 squared equal to 4 squared times 3 squared. So this would be 12 squared. This would be 16 times 9 is, and b are constants, is a times b equal to a squared. Okay. All right, we got a second opinion, seems to be fine. Okay, so that means our calculator seems to be doing all right. Okay, so I think we can move on to actually adding this into our toolkit. 7, F7. Okay, so now we have to match these. So y, x, y, x, y, x. Okay. So I'm doing left to right, top to bottom. So y, a, v naught, theta, y, x, v naught, theta, y, x, v naught, theta. Okay, and that's it. Y, x, yxa v naught theta. Yxa v naught theta. Okay, so we're using equation 7. So y, swapping these. V theta, okay. So y, enter initial height, I think. All right. X, enter end distance, enter acceleration. V naught. Theta, angle in degrees. Result will be yy, xx, aa, b, b. And it should be 7 now. All right. So I want to use 7. Okay, so we're solving for y. 39.8. 39.8. Solving for y. End distance is and I just deleted it. Oh. Okay. I was almost very upset. Okay, so why is this? So they're solving. So confused. Are we solving for y or x? Seems like we're solving. Is x 0 or is y 0? Okay, we're gonna say it is 0. Let's say y 0. Seven. 0. Solving for x. 9.8. Initial velocity. It's 31. 31.9. 31.9. 30 degrees. Getting 0. I guess we could use two variables, couldn't we? 7, height is y, and distance is x. 9.8, 31.9, 30 degrees. Getting this needs an x in front of it, doesn't it? I think I missed an x. We should have an x. So all this should be times by x. Okay. Maybe that would fix it. Times a divided by times x minus x times this. Okay. Okay, so 7 y x 9.8 31.9 30. So we are getting, we're getting solve for x. What if we want to solve for y? We want to solve for y. Loading. It's working. It's working. Okay. I guess it doesn't like the big numbers. Okay, and this is not even right. So x should be on the inside. X should be on the inside. So that's probably why it's x should be that is right. Ax a x squared. Okay. Okay. I'm gonna say this is not the best example for that. Um, Earth's surface drops 5 meters every 8,000 meters. Alright, I guess we're not. Guess we're not learning about. Guess we're not. I guess we're not doing that. There we go. Alright. Yeah, this is pretty cool. I'll give him that. This is pretty cool. See, there's always the force of gravity. Boom, it's at rest. About 4 minutes left. So you can change the diameter of the ball as well. Okay, well, that one's gone. That one's gone. A very dense. What about a very dense one? Diameter definitely matters a lot. You gotta think more diameter, more air resistance. See, whoever made this, they definitely put a lot of work into it. I respect it. Drag. Drag coefficient. Drag coefficient. So higher drag coefficient, whatever that is, makes it go farther. Altitude. Don't know what that does. What the lab. Hmm. Pretty cool stuff. I'll give this as a 10 out of 10 of all the ones I've tried thus far. I'll give it a 10 out of 10. All right, so made some progress today. We added some new equations. F this function 7, we might need to work on it a little bit more, but maybe not. This one's pretty cool. Calculates initial velocity. Um, yeah, new way of doing things, I guess. So again, same thing. Hardest part is finding the right equation for the problem. Yeah, we'll end it there, and we'll pick up where we left off next video. So thanks for hanging out.